y equals 1/2 f of negative 2x minus 4 plus 3. So the nice thing about this one, it's already factored, which is most of the time. So that negative 2 on the inside of f, just always make sure that number is factored out. So we're good to just kind of label everything to start. So my a value is 1/2, and that's a vertical compression by a factor of 1/2. The b value is negative 2, and you always have to remember that's two things because it's negative. So because it's a negative, it's a reflection in the y-axis. And now we got to deal with the 2 on the inside. Because it's on the inside of f, everything on the inside of f is always kind of opposite of what you'd expect. So usually I think if something's a 2 that it would be an expansion, but because it's inside of f, it's actually a horizontal compression by a factor of 1/2. So it's always the reciprocal. So because that's a 2, we flip it. When we put them together, the horizontal compression and the reflection, because it's a reflection in y, we do those together. And all we're going to do is multiply x by the reciprocal of negative 2, which is negative 1/2. Now the h value is also inside, so that's x minus 4, but again, it's kind of the opposite. Minus, I would usually think, is going to go left, but it doesn't. It actually is a horizontal translation 4 units to the right. And you'd think h is a negative, but it's actually a positive. So everything inside those brackets that hold f, that f's holding, they're always the opposite. So the negative 2, you actually multiply by negative 1/2. The x minus 4, you actually add 4. And last, k equals positive 3, which is a vertical translation of 3 units up. Okay, now we can start mapping out how we're going to change x and y. I've kind of color-coded everything above, so the green ones affect y and the red ones affect x. So I'm going to multiply my x value first by negative 1/2, and then I'm going to add 4 to that to move it 4 to the right. Then I'm going to multiply the y value by 1/2 and add 3 to that to move it 3 up. Now we need some points to actually do this to. So when I look at this graph, which is a funny little mountainy something, I got to pick the points that we're going to actually move so that we can keep the shape though properly. So when I look at this, there's 4 key points. So I'm going to just label them, and those are the points I'm going to move. So there's point A at negative 4, 0, point B, which is at negative 2, negative 2, point C, which is at 2, 2, and point D, which is at 4, 0. Now we're just going to stick these coordinates into our little formula. So A, which is negative 4, 0, is going to become negative 1/2 times negative 4 plus 4. And then the y value will become 1/2 times 0 plus 3. So A prime is 6, 3. B, which is negative 2, negative 2, putting it in, I'm going to have a negative 1/2 of negative 2 plus 4 and 1/2 of negative 2 plus 3 to get a B prime, which is 5, 2. Then C, which is the point 2, 2, is going to be negative 1/2 of 2 plus 4 and 1/2 of 2 plus 3. 1/2 of 2 is 1. So negative 1 plus 4 is 3, and 1 plus 3 is 4. Then D is the point 4, 0. So I'm going to get negative 1/2 of 4 plus 4, which is negative 2 plus 4, which is 2, and then 1/2 of 0, which is 0, plus 3 is 3. So D prime is 2, 3. Now we just have to plot these points. So here is A prime, B prime, C prime, and D prime. And then we're just going to connect them in order. So A to B to C to D. Okay, it's been a long question, but still, the last thing I would always do is make sure this makes sense. So when I look at this, I go, okay, it's compressed by a factor of 1/2 in both directions. Well, it definitely looks smaller in both directions. Does it look like it's been reflected across the y-axis? Well, for this one, it's kind of tricky because a reflection through y and a reflection through x would look exactly the same. It definitely looks like it's been moved to the right and moved up. So always, once you're finished, try to look at your graph and just make sure it makes sense.